Alright, so this is our second example in the related rate section, and here's our problem. Sand falls from an overhead bin, accumulating into a conical pile. The radius is always 3 times the height. If the sand falls at a rate of 120 cubic feet per minute, how fast is the height changing when the pile is 10 feet tall? And here I'm giving you the volume of a of a cone. The volume of a cone is 1/3 pi r squared h. Okay, so again, we're given that the sand is falling at a rate of 120 cubic feet per minute. How fast is the height changing when the pile is 10 feet tall? And so clearly, right, the volume is changing with the height and the radius for that matter. Okay, so pause for a moment and see if you can draw a picture and label the things that are changing. And if anything is constant, be sure and label that as a constant and not as a changing quantity. Okay, so pause here for a moment and we'll be back. Good, so the picture you have hopefully looks like a cone, upside down cone kind of, I guess you could say. So there's our cone, and so here's our height h of t actually. H of t is the distance up, and so here's our radius r of t. Oops. And we know that volume is, and this is a function of t, so let's go ahead and say that. Volume of time is 1/3 times pi times r of t squared times h of t. Okay, so if you've gotten this far, let's see what we need to do from here. So one thing we do notice here is that we actually have two functions here. Can we simplify this a little bit? I think we can with what's given, right? Because the radius is always 3 times the height. So therefore, do we want our volume in terms of the radius, or do we want our volume in terms of the height? I think we want our volume in terms of the height, right? Because we're asked to find the volume when the height is 10. So let's go ahead and rewrite that. So I'm going to put something in place of r, and I'm going to put h. I'm going to try to write the radius in terms of the height. So I know that the radius is 3 times h, right? And so therefore I can replace my r by 3h, and so my volume, I'm going to suppress the time dependence for a second. So that's going to be pi, and then my r is 3h squared times h. And so my volume now is 1/3 pi, geez. Let me go ahead and take out the 9 here. 9 divided by 3 is 3 pi. Then I'll have an h squared and an h, so that'll be an h cubed. Good. All right. So now what we want to do is we want to find how fast is the height changing. So find dh over dt when what is true? When h is equal to 10. Do we know anything else? The sand is falling at a rate of 120 cubic feet per minute. So how would you translate that piece of information? The sand is falling at a rate of 120 cubic feet per minute. I think that is the change in the volume, right? So the change in the volume, oops, dt, is going to be 120 cubic feet per minute. And that is a positive, right? Because it's increasing. Good. Okay. And so you might pause for a minute and see if you can finish up the solution from here, and we'll be back with the solution. All right, so we're going to go ahead and solve this now. So this is just, we'll take our equation here that we finished with, and we'll differentiate everything in terms of t. So therefore dv over dt is equal to 3 times pi, and then this part is a chain rule, so that's going to be times 3 times h of t squared, right? That's the derivative of the outside function, and then we multiply by the derivative of the inside function, which I'll write as dh over dt. Good. And now we plug everything in. Do we have all of our information that we need? dv over dt is 120. And then here we have a 9 pi. h of t is 10. So 10 squared is 100 times 100 times, and dh over dt is our unknown, right? This is what we want to solve for. Solve for this. Good. And so basically everything's done, right? So dh over dt is equal to 120 over 900 times pi. And so on a calculator, you could compute that to be approximately 0.042. Do you know what the units will be? Let's see, what were the units of time here? Feet per minute, I guess, feet in minutes. So this would be feet, whoops, sorry about that, feet per minute. Good. So I think we'll stop here, and then in the next video we'll do another example. So we're just going to do one example per video. I think it'll be easier to locate the examples that way. See you in the next one.